In this video, we're going to explore confidence intervals for population proportions. Now, a population proportion is just the proportion of success in the population. We've dealt with this before, and we've often looked at sample proportions because we're typically dealing with sample sizes. It's very difficult to get all the proportion from a population. And the way we found it before is we took the number of successes and divided by the sample size. Important thing to recognize is that when we talk about the sample proportion or the point estimate for p, we use p hat. Okay, it has that little symbol over top that we call hat. Also, just like proportions we dealt with before, if we want to find the sample failure proportion, that's q hat, which is just 1 minus the proportion for success. When we need to find margin of error, we do use the z-score, and then inside we have the square root of p hat times q hat divided by the sample size. And then we do our confidence interval just the same way, where we're going to take our proportion, add and subtract the error. Now, one thing we do have to check is down here, whenever we're going to make sure that we can actually find the confidence interval, we need to check to make sure that we can take our sample proportion for success, and when we multiply it by sample size, that's greater than 5, and that the proportion for failure times the sample size is greater than 5. That is an important component that you should always check. So let's look at an example here. Say I've got 900 adults, and 63% are believed to be teenagers, or believe that teenagers are the most dangerous drivers, and I want to make a 99% confidence interval. So I want to start with what I know, which is that the proportion who think that they're bad drivers are 63%, which means that 37% of the people don't believe that. My sample size is 900, and then I find my critical value because I know it's 99%. That's one of those critical values I should know, which is 2.575. Or I could use Excel and plug it in there using the norm.inv formula. With my margin of error, I just plug in the pieces. My critical value, proportion for success, proportion for failure, sample size. And I simplify. Now, you notice how this was in percents, and here I'm using the actual proportion or the decimal values. You have to use decimal values when you figure out your margin of error. The same thing when we put together our confidence intervals. When we talk about p hat, we need to do it as the decimal value. Okay, so we want to make sure that they're all consistent, or it's going to look kind of weird. So we add and subtract the margin of error, and we get about 58.9% and 67.1% that we would expect the population proportion to be within. So we can say that we are 99% confident that the proportion of adults who believe teenagers are the most dangerous drivers is between 58.9% and 67.1%. Now, if we want to find the minimum sample size to estimate what our population proportion would be, we can use this formula here, where we take our sample proportion for success times our sample proportion for failure, and we multiply it by the critical value divided by the error squared. Now, one thing to recognize is that we may not always have the p and the q hat. When that doesn't happen, we can still do it by using 50-50, 50% for each of those. By using 0.5 for each of those values, it actually maximizes the number in our sample size. That would be the largest amount we would ever need. So we can still do it, we just got to remember to use the 0.5 right here. Here's an example. Say that I want to create a 90% confidence interval, and I know that my sample proportion for success is 35%, and I'm accurate within 2%. This accurate within, that's my margin of error. Because we're talking about percents, we say accurate within. So I have p hat's 35%, q hat's 65%, a 90% confidence interval is the 1.645, and then my error 0.02, because that's the 2%. Plug in the components I have, and you can see I just simplify this fraction and square it, and then I get about 1,539 people. So that's about how many people I would need to get my proportion.